I'm looking in the book. Let's choose, or we can make one up. Type 3. Okay, let's say, let me look at which problem we did last time because I don't want to repeat the same thing. I think I made it up. Okay, so type 3, I will choose problem 86 on page 427. And here's type 3. Let me ask you, what is this? What type of function is it? Yeah, I had to do it like 3 times. What type of function is this? Say it again. Okay, I didn't hear that. I didn't hear anything. So one more time. What type of function is this? Rational function. It's a ratio of 2 polynomials. Very good. And what type? Say it again. It is type 3. How do I know it's type 3 of a rational function? Higher in the numerator. Excellent. That's all I needed to hear. Good. And I would like to fill up my chart. Once I'm done, I will be able to graph it. Where do I start? Very good. What is the domain of this function?
Negative infinity to 1.
Negative infinity to 1. Union?
Union 1 to infinity.
Very good. Do we all understand why 1 must be excluded? Yes? Yes? The denominator cannot be 0. X minus 1 equals 0 means x equals 1. Are we okay, everyone? Okay, perfect. So, I'm sorry? Say it again.
I think I heard you mention 1, 2, 3.
Why I mentioned 3?
Yes.
So why I wrote that 3, Roman 3 up there? Is that?
No, he mentioned that the domain is 1, 2, and 3.
No, he said negative infinity to 1, union 1 to infinity. Is that okay?
Yes.
Okay.
How did you say that again? You said negative infinity to 1?
Negative infinity to union 1 to infinity. It's undefined at 1.
Oh, okay. That's what you call it. Okay.
Yes, we don't have to write it. Once I see it in the chart, I'm fine. And if you put undefined here, then I know. Now, if you want to write it on the side, you will write that the domain is negative infinity to 1, union 1 to infinity.
Got you.
It's either or. You don't have to do both.
Okay.
Is that okay, everyone? So far? Okay, perfect. So, is this factorable?
Yes.
The answer is no. X squared minus x plus 1 is not factorable. Let me show you why it's not factorable. Let's take it aside. Let's find the solutions using the quadratic formula. X equals. We cannot forget the quadratic formula.
Negative b.
Okay, plus or minus. So negative 1 plus or minus. Yes, 1 minus
4 is
over 2a. Is this factorable?
no.
No, because the square root is of this negative 3. So I know this is not factorable. And furthermore, it has no real solutions. Good, because I'm going to ask you next, since this is not factorable, do you think x minus 1 will go away from the denominator? Why would I be worried whether x minus 1 goes away from the denominator? Well, I'm worried because if it does go away with a factor from the top, what would happen there?
Zero.
Right. But since the top is not factorable, it has imaginary solutions, right? Will x minus 1 go away? No, it doesn't have anything to go away with. So then what do I conclude about x equals 1? Because I have to write it in my chart so I don't forget what it means.
What's your vertical asymptote?
Awesome. It is a vertical asymptote. If it doesn't go away with the factor from the top, it's not a hole in the graph, so it must be a vertical asymptote because the function is undefined there. Are you with me, everyone? Clear? Okay. Once I establish this, what is my next step in the chart? I'm not there yet. I have to finish here. Exactly. Since I'm here, it's not wrong to move to the x-intercept and so on and so forth, but since I'm here, let's exhaust whatever I need, everything I need about the vertical asymptote. So once you said the vertical asymptote, I put the infinities, but what I don't know is
Plus or minus.
exactly. So I will be using 0.9 and 1.1. Notice the fact that I put them out there because I'm not going to graph anything. I'm not going to plot those points. I put them up there just to show that I'm using them. This has imaginary solutions. In other words, we tried to find the x-intercepts of this. So we couldn't. So now I'm going to ask you, if you just look for a moment only at this top, what type of function is it? Thank you. So it is quadratic. Does it open upward or does it open downward? Upward. And it does not have x-intercepts. What type of number will that be always?
Positive.
Exactly. It's way above the x-axis. So no matter what I plug in here, because I don't want to waste my time. I don't want to plug anything in here if it's always positive, right? So this is always positive. But now when I plug in 0.9, tell me the sign. Awesome. Please plug in 1.1.
Positive.
That's it. Notice that I did not waste my time to plug in anything at the top because I know that x squared minus x plus 1 is quadratic, has a minimum, and it does not touch the x-axis, meaning it can never be negative. It's way above the x-axis. Perfect. So I finished with domain, vertical asymptote, behavior near the vertical asymptote. Now I would like to continue with, Heather is right, x and y intercepts. But a fraction is 0 when the top is 0, but there are none. No x-intercepts. So the only thing I need to do is plug in 0. So let's plug in 0.
That's one.
0.
So 0, 0, 1, 0, negative 1. That's why I covered them. So when x is 0, y is?
Negative 1.
Correct. It's 1 over negative 1. Is that correct? Okay, negative 1. Good. Almost done. I'm missing one thing. What am I missing? Yes, you're right. Let's write the symmetry. A function with a vertical asymptote at 1 cannot be symmetric. But I will write f of negative x definitely will not equal f of x, and it will not equal negative f of x. Not symmetric. Good. So then what is the last thing I need? Exactly. And then behavior is always connected to one of the following two things. Or which one? Not both. Exactly. How do I determine the slant? What do I have to do? We have to divide, remember, the quotient of this division, degree 2 over degree 1, just the quotient will be the slant asymptote. Can I use long division or synthetic division? I should ask, can I use synthetic division here?
Yes.
Yes, because the denominator is x minus a number or x plus a number. Do you want to use long division? Because long division always works. Do you want to use long division or synthetic division?
long.
Fine.
No, what are we trying to
That's
find?
one.
We are trying to find the slant asymptote and the end behavior. And we are done.
It would be x minus one. X squared minus x squared.
Very good. Good. So the first question is, x multiplied by what is x squared?
X.
Very good. At the top, we don't lie.
X.
Yes, x. Good. At the top, we don't lie. Good. Now I distribute. X times x.
X squared.
And now I lie. X times negative 1. Now I have to lie. And bring down the next in line. I cannot continue.
So,
Damon?
what are you talking about lying?
X times x is x squared, but I have to write the opposite, as I showed that numerical example a long time ago, because I have to subtract.
You know how we forget.
Okay. No, I'm just saying if you want to go back and, yeah. So x times x is x squared, but I have to write negative x squared. X times negative 1 is negative x, but I have to write positive x. Yeah, and then I perform the operations I see, and then I bring down x, and I cannot continue. X times what is 1? I don't have an answer. So y equals is what?
X minus
Y equals x is the slant asymptote. That's it. Just the quotient. So if you want to change this function, so from f of x, x squared minus x plus 1 over x minus 1, how will you write? Forget about this for a moment. Let's just write it.
X equals to 0.
Just tell me what is the division? What is the result?
0,
One.
1. 1 and 0.
You have to write the quotient first, right?
There's 0. X equals to 0.
You have to write the quotient first, right? So it's x plus,
1 over x minus 1.
that's it, right? Only the quotient is the slant asymptote. Only the quotient is the slant asymptote. Well, I know we only did one problem last time, so not enough. Oh, I know that.
So how would you put that on the graph?
Okay, we'll see in a minute. Y equals x is a slant asymptote. I will graph the function y equals x that we know how to graph. We graphed y equals x when we used transformations. We graphed y equals x when we graphed the function and its inverse, because they have to be symmetric with respect to y equals x. We have it on the list of functions from transformation. It's another line. And it's a line because the degree of the top is 2 and the degree of the bottom is 1. When I divide degree 2 by degree 1, I get degree 1. When I talk about a function degree 1, what do I have in mind? The line. And that's the line. But we need more practice. I completely agree. Good. So now please give me the end behavior. Does the y equals s looks like this? If you say yes, then I'll have to write negative infinity to positive infinity. If y equals x looks like this, then I have to write for the end behavior positive infinity to negative infinity. Which one is it? Positive slope or negative slope? Correct. So if you say positive slope, then what do I have here?
Negative.
Correct. Agreed? And what do I have here?
Positive.
Right, because the function has to follow the asymptote. Good. So let's see if we can make sense of all this information. Let's do this together. Okay. So from approaching the asymptote towards negative infinity, right here, it's coming up, crossing the y-axis at 0, negative 1, and then it drops to negative infinity on the left-hand side of the vertical asymptote. One more time. From approaching the slant asymptote towards negative infinity, coming up to 0, -1, and somehow it turns, and it goes down to -infinity on the left-hand side of the vertical asymptote. On the other side, it's coming from +infinity. It has to come to a minimum because it goes up to infinity to follow the slant asymptote. Coming down to a minimum and continues towards approaching the slant asymptote. So let's give it a shot. It makes sense. So when I graph a function with asymptotes, what do I have to graph first?
Asymptotes.
Very good. How many asymptotes does this function have? As you notice, I don't care about anything else but my chart because it contains all the information I need. 2 asymptotes, very good. Which is the first one that I have to plot? It doesn't, the order is not important. Which, yes, which is? You cannot say 1. X equals 1. Because I don't know what to plot. When you say 1, I don't know if you mean y, I don't know if you mean x. Although I know you said it's a vertical asymptote, but we have to write x equals 1. I know that you're on the right track. Good. Which is the other asymptote that I have to graph? Which is? Very good. And we know how to graph that for months now. So this is y equals x. And this is x, this is the origin, and this is y. Ready? Let's look at the chart one more time. It says, from approaching the slant asymptote towards -infinity, must cross the y-axis at 0, -1, and go to -infinity. I don't know if it turns there. For now, I'm going to say it turns there. I will verify that with a calculator in a minute. Is the left-hand side clear? Yes? Okay, let's look at the right-hand side of the asymptote. From +infinity, no function can do this. Right? Has to do this. So it's coming from +infinity to a whatever minimum and eventually approaching the asymptote as it should. From approaching the asymptote here, approaching the slant asymptote here. Both infinities. So there must be a minimum somewhere. I cannot determine these. For example, this minimum, I cannot determine it without the graphing calculator. But this is for sure the graph of f of x, which is x squared minus x plus 1 over x minus 1. It's not an easy graph. I will never say that this is an easy graph. No. And I will not put it, I will put it as an extra credit. I think the first 2 functions are good enough. So this one will be an extra credit to choose from. I will ask you to find the slant asymptote in the test and so on and so forth, but I'm okay with graphing the previous 2, type 1 and type 2. Okay, so let's still put it in the graphing calculator. And the top in parentheses, x squared minus x plus 1. I don't think it's, yes, please, I'm sorry.
And this is a question though, if we get the extra credit wrong, does that take off credit from?
No, of course not. Okay, is this the only function that we put in? Or is there anything else we have? Yes, which is? We can never
Y
put
equals
x.
Y equals X.
Yes, there is no x here. So all of them are y. So the other one is y equals x. Very good. I'm going to, for now, use the standard viewing window. I'll say zoom 6 and see what happens. Here it's coming. Ah, it's turning. It's turning again, and here comes the slant asymptote. So I want to investigate whether it turns here on the y-axis, and I have to determine that minimum. So in order to determine this maximum here, I'm going to say between -1. I cannot put in 1. Between -1 and 0.5. So second in calc, and I want a maximum, which is 4. between -1, enter, and 0.5, enter, and enter again, and I don't want to guess. Good. So let's analyze this number. Blah, 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 e -7. What does this mean? Exactly. It means that this decimal point has to go that way 7 spots. 0.000000703, which is a way the calculator said 0. So indeed, the turn is at 0, -1. And now I have to find this minimum. And I see it somewhere between 1.1 and 3. So second and calc, I want a minimum. Between 1.1, I cannot put in 1 because it's undefined, and 3. And I get 2, 3, roughly. So 2, 3. That's all I needed. So this is the local minimum, 2, 3, and this is the local maximum, 0, -1. I don't have to make any adjustments to the graph. This is it. Is this okay? Do you need any help with the calculator?
No, I'm good today. I got it.
Good. Anyone? Damon? Are
You
you?
wanna do another one?
I'm sorry?
Would you like to do another one?
Yes.
Oh,
Okay, do you want to choose? Which type are we doing now?
let's not go too far. Let's, for the sake of the class, I guess they like to do number 88.
88.
Mhm.
Okay, let's do 88. But this is type 3. You still want type 3?
Oh, it's still type 3?
It is type 3. The degree of the top is 3, the degree of the bottom is 2. It's still type 3.
Oh, it is, huh? Oh, okay, that's the same, okay. All right, so
Uh,
number 80 then.
Which one? 80? Very good. We have f of x equals x squared minus 4x, and I think we did this problem together. Let me look.
Oh, okay.
I don't know. Did we?
Maybe so.
No? No. Very good. Good pick. Very good. Okay. What type of function is it? No, it's not quadratic. It is rational because it's a ratio of 2 polynomials. Very good. Good. What type?
Type 2.
Nope. What is the degree of the top?
Same degree, so type 1.
Exactly. It is type 1. Degree of the top is, the degree of the top is, and the degree of the bottom is? Exactly. Very good. What is my next step?
Make a chart.
Yes, but of course I need to factor the top. Can anyone give us the factor form for the top? Very good. Good. Perfect. Thank you. So now I need to find what? Always remember, if you agree to use the chart, if you have a different method, and Damon and I were looking at the book, I just want to show you how the book treats this, because it's difficult to put math in writing. So from page 411, and there is absolutely no summary of what they are finding. Look, they say step 1 through step 7. Now graph the function, but there is no summary of anything. So I'm not sure how a student will just go through all these steps and try to figure out the graph. I'm not sure. So that's why I encourage you to try to understand this graph, the chart that we use for polynomial functions and we are using now for rational functions, because it summarizes all the information. And you have it right there, and by reading the chart, you will be able to graph the function. Now, if you say, I don't like your summary, I can make my own summary, I'm fine. Okay? So, next step. Once I fill this up with what I need from that list of 8, 9 items, then I'm done and I'm ready to graph it. So what will be our next step then? Exactly. Awesome. So what is the domain of this function?
Negative, infinity, positive.
Why 1? Exactly. Because -1 plus 1 will be 0. 1 plus 1 will be 2. 1 is fine. So one more time, what is the domain? Yes? Yes? That's it. Very good. So we must exclude -1. Do we all agree with excluding -1? Yes? Because x plus 1 cannot be 0. Very good. Okay. Now I need to identify what happens at -1 since I'm here, since I'm talking about -1. Tell me what to write under -1. Do we all agree with the vertical asymptote here? Why? How come that it's not a hole in the graph?
Because they don't cancel out.
You cannot cancel out x minus 1 with a factor of x plus 1 with a factor of x plus 1 from the top. Very good. So indeed it's a VA. Once you say it's a VA, what will be the next step immediately? Yes. So then using -1.1 and -0.9. Is there a point in plugging in this expression anything? Why? Is there any point in plugging here -1.1 or -0.9? Is there any point? Or will I waste my time? I will waste my time. Why? Because whatever I have to square it. So the bottom is always positive. Don't worry about it. Is that clear? -1.1 plus 1, whatever it is, I have to square it. -0.9 plus 1, whatever it is, I don't care. I have to square it and it will always be positive. Good. So let's plug in -1.1 here. Just give me the sign. Awesome. Plug in -1.1 here and just give me the sign. Awesome. 2 negatives. Very good. Let's plug in -0.9. Very good. Let's plug in -0.9. Good. So then the sign here. Good. If you remember, there are 4 possibilities for a vertical asymptote. This is one. This is the other. And here are 2 more. Which one will this be? Very possible. That's why you cannot conclude before you plug in both numbers. Not at the same time, of course, but you check the sign for both, left and right. Is that okay? Good. Next. I exhausted all this. It's done. Now what? Yes. So the x-intercepts. How do I determine the x-intercepts for this function? What do I have to do? Say it again. It's 3 because a fraction is 0 if the top is 0. When is the top 0? When x is 3 and when x is 1. So 1, 0, 3, 0. Be careful where you put them in the chart. They have to be to the right of 0.
What was that statement you made again? You said when x is 0, what? You said when something is 0.
A ratio is 0 only when the numerator is 0. Our numerator here is x minus 3 times x minus 1 set equal to 0, means x equals 3 and x equals 1. Is this okay? Everyone? Perfect. Good. What else I need? Y-intercept. Awesome. How do I find the y-intercept for any function? Indeed. Thank you very much. 3. Okay, one more step. What else do I need? Very good. Does it have a horizontal or a slant? Yes, because it's type 1. What is the recipe for a horizontal asymptote type 1? What is the recipe for a horizontal asymptote for a function, rational function type 1?
The leading coefficient over the bottom.
Over the leading coefficient of the bottom.
Right.
Awesome. What is the leading coefficient of the top?
1.
Awesome. What is the leading coefficient of the bottom? Good. So what is the horizontal asymptote?
1.
And the end behavior. Awesome. So all we need is practice. That's that's why I can't miss 2 classes. I just absolutely cannot. Very good. Now I'm going to think about this and see what I come up with. Ready? Yes, please.
I'm sorry, where'd you get the one from? I know you said leading coefficient, but,
Leading coefficient is 1. Leading coefficient is 1. 1 over 1 is 1.
oh, okay, got it.
And that's the horizontal asymptote and the end behavior. Yes, Damon?
How do you get the y again? The y axis. The y
Intercept.
y intercept.
0, 0, 3. 0 plus 1, 1. 1 squared 1. 3 over 1, 3.
Okay.
Better?
You should put 0 all within there. You put the 0
To determine the y-intercept,
Okay.
yes, I have to make x equal 0.
Okay. X is 0.
Are you with me? Okay, let's try and make sense of this information. I know I look silly when I do this, but I'm hoping that this will trigger your memory. From approaching 1, the function goes to infinity on the left-hand side of the vertical asymptote. Pretty clear, right? From approaching 1 to infinity. Is that okay? Good. Now here. It's coming from infinity, crossing the y-axis at 0, 3, crossing the x-axis at 1, 0. It has to turn because it has to cross again at 3, 0 and get closer to 1. One more time. From positive infinity crosses the y-axis at 3, 0. It crosses the x-axis at 1, 0. It's below now, below the x-axis now, but it has to come back and cross at 3, 0 and approach 1. Ready? I only care for this. Nothing else matters. Good. So when I graph functions with asymptotes, I'm going to ask you the same thing, the same question in chapter 4, because there are other functions there with asymptotes. So when we graph, that we will look at. And after this, I'd like to look at an application, but after we cover 3.6. When I graph a function with asymptotes, what do I have to graph first?
Asymptote.
Good. How many asymptotes does this function have? Please dictate.
What's the other? It's negative 1.
Vertical asymptote is 1.
No?
X equals 1.
Very good. X equals negative 1. Anything else? Very good. Awesome. Perfect. Good. So let's look again. Good. So from approaching 1 to infinity. Is this clear? It does not touch any of the asymptotes. It approaches. Now, I have to draw this or plot this point. I have to plot this point, and I have to plot this point. From negative infinity, crosses. Oh no, I'm sorry, I'm sorry, I'm sorry, I'm sorry, I'm sorry. I'm sorry. It's 0,3, not -3. Okay, from positive infinity, coming down, crossing, crossing, turn, crossing again, and approaching 1. What did we say? Can a function cross a horizontal asymptote? Yes. Can it cross a vertical asymptote? No. Can it cross a slant asymptote? Yes. Anything but vertical. Very good. With the graphing calculator, the only thing I have to determine is this. So let's do that. So in y equals, clear, clear, and I put in x squared parentheses, x squared minus 4x plus 3, and divide by x plus 1, close the parenthesis and squared. Is there any other function that I have to put in? Which one? Perfect, awesome. I'm going to say for now the standard viewing window. If I don't see what I should see and what I know that is correct, then I'll make some adjustments. I know the calculator is lying. The function doesn't come from positive infinity, crosses at 0, 3, and it follows the x-axis. That's a total lie. The function has to do this.
Right.
So then I go back and I change my viewing window. And I'll say, I'm looking at the graph, -5 is good enough. +6 may be good enough, I'm not sure, we'll see in a minute. Y minimum, -2 at the most. And Y maximum, 5 at the most. And graph again. Much better. However, I really don't see this minimum here. So I'm going to zoom in. I only care about that. So I'm going to go back to the viewing window, and I'm going to say for Y value, -0.5 to +1. Exactly what I was expecting. It crosses at 1, 0, it crosses at 3, 0, it comes to a minimum, it has to turn, and eventually gets to 1. So now I can determine this minimum between 1 and 3. Do not trust the calculator, trust your instinct. So it's a minimum, so I want 3, and I want between 1 and 3, and give me the minimum. So the minimum is at 1.67. 1.67, and the minimum is -0.125. Is this clear? Do not trust the calculator is lying to you.
I messed up the window.
Yes, so,
I deleted it already.
oh, you deleted the function?
Yeah, I messed
Oh,
it up.
that's
I
okay.
mean, I put it in there, it was right, but I just didn't.
Okay.
It's okay.
Any questions? Any questions? Okay, let's look at the last section. What I would do, and I highly recommend that, I will redo the problems we did in class first till you understand each and every item. I would definitely look at the problems that they present in the book, and I will organize the information the way I want. So I can read the chart or some summary that helps me graph the function. Any questions?